On the 24th of March 2026, NASA gave us a huge amount of information on their plans for a moon base as part of their Artemis program. This project aims for a sustained return to the moon and later Mars. A quote from Jared Isaacman, the new NASA administrator. On the moon, we are shifting to a focused, phased architecture that builds capability landing by landing, incrementally, and in alignment with our industrial and international partners, unquote. The directives from NASA can be summarized as establish a permanent presence on the moon, accelerate the schedule, and leverage commercial providers as much as possible. Going forward, NASA contracts will be firm fixed price, replacing the old cost-plus approach which led to enormously expensive rockets like SLS. This video will mainly cover the information provided by Carlos Garcia Galan, NASA's moon base guy as he called himself, at the Ignite event held at NASA's headquarters. In a nutshell, the plan is to cancel the Lunar Gateway Station, repurposing the existing hardware. The power and propulsion unit will be used on the SR-1 nuclear-powered spacecraft scheduled to head to Mars. The solar panels on the unit will be deleted and replaced with 20 kilowatt nuclear reactor, using the existing powerful ion thrusters. NASA's decision to focus on the lunar surface simplifies architecture, increases launch cadence, accelerates tech and science payoffs, and supports commercial lunar startups and the broader space economy. Other completed gateway modules could be repurposed into habitation modules for the lunar base. We also learned at the Ignite event that the human landing system providers, that is SpaceX and Blue Origin, would prefer to switch to a low lunar orbit for rendezvous operations around the moon. NASA had planned to use a weird NRHO orbit because the Orion capsule is too heavy to reach low lunar orbit. This simpler orbit used by the Apollo missions would pass over the same point on the lunar surface every 2 hours, providing better abort options back to Earth. Under the evolving post-Artemis 5 architecture, SLS will deliver Orion only to low Earth orbit. From there, the capsule will dock with a waiting lunar starship that carries the stack to lunar orbit. While the Orion capsule is heavy, it only adds around 2% extra mass compared to a fully fueled Starship, so Starship will have no problems delivering Orion to low lunar orbit and then completing a lunar landing and lunar ascent. With a new commercial upper stage for SLS after Artemis 3 and commercial super heavy launchers used post Artemis 5, the plan is coming into clear focus. Building and sustaining a moon base will be done using commercial launchers and landers instead of the government designed and built vehicle approach of Apollo. In my view, this is a far superior approach to China's moon base, which appears to be top-down, centrally planned operation. Indeed, a recent request for information from NASA is looking for additional providers for human transportation services from Earth to lunar orbit. NASA intends to purchase crewed missions to the moon every 6 months, with the current HLS providers handling the lunar landing and ascent missions. NASA's new plan is slowly building out a commercial economy in cislunar space, the region extending from Earth's surface to just beyond the moon. This area will become integrated into Earth's economy, with many services provided commercially to paying customers. A sustained presence on the moon requires private customers buying commercial services with no government involvement. We have one early example already, Maybell Quantum, a company building specialized refrigerators for quantum computers, signed a contract with Interloon for the delivery of helium-3 from the moon starting in 2029. Hey everyone, quick thing before we dive in. Join my weekly live stream this Saturday. It's a community of space nerds discussing the news about space startups, including rocket launch companies, the orbital economy, and lunar development. I recap all my videos this week, including slides, images, and extra content that wasn't included in the videos. After each video recap, I read some of the best comments from viewers and answer chat messages. Ask me anything on any space topic, or just chat among yourselves about the latest space happenings this week. The more people chatting, the more fun it gets. So drop your comment right after watching the video, and I'll see you this weekend for the full recap and live Q&A. Find the live stream link in the pinned comment for this video. Okay, let's look at all the phases of the moon base, starting with phase 1. Phase 1. Build, test and learn. We are in Phase 1 now. This covers the period 2026 up to the end of 2028. During this period, NASA plans to fly many robotic missions, packed full of scientific experiments and tech demos, to learn more about the lunar South Pole through surveying and exploration missions. This phase offers opportunities for startups to fly lunar technology payloads quickly, assuming they're in line with NASA's goals, to reduce risk and verify equipment works as expected. From lunar prospecting to power and communications, moon rovers or landers, many lunar startups will have the opportunity to test and verify their equipment thanks to NASA's new high-cadence lunar missions. In fact, NASA is planning 30 missions over the next 3 years. That's almost a landing every month. That may seem impossible, but it's possible with enough providers. We already had missions from Intuitive Machines, Firefly Aerospace and Astrobotic, with Impulse Space announcing last year their plans for 2 missions per year to the moon, starting in 2028. That's 4 providers. iSpace US is also working on a larger lunar lander for NASA CLIPS missions, so NASA is close to having enough commercial lunar landers to reach the high cadence of missions they're planning. Phase 2. Establish the early infrastructure. Phase 2 starts in 2029. This phase will see the very first habitation modules on the moon, followed by the first human presence since the Apollo missions in the 70s. Expect to see cargo landers and the first power systems and communication relays. The Japanese Space Agency's Lunar Cruiser vehicle, a pressurized rover, will be delivered to the lunar surface in this phase. This will allow extended human missions away from the initial landing area. It's likely the very first nuclear reactor will be deployed on the lunar surface, generating at least 100 kilowatts of continuous power. That's more than enough to power a base camp for 4 crew. Heavier cargo vehicles will land in this phase. Blue Origin's Mark I cargo vehicle can land 3 metric tons, while ESA's Argonaut vehicle can land 1.5 tons. Starting in 2028, Impulse Space's lunar missions are capable of landing 3 tons per mission, with 2 missions per year every year. Blue Origin's Mark II crewed vehicle can land 20 metric tons in reusable mode and 30 tons in expendable mode. SpaceX's Lunar Starship can land 100 metric tons to the lunar surface, providing massive cargo capability to support a lunar base. With Elon Musk doing his own pivot to the moon, SpaceX is now fully invested and focused on building its own moon base. It's worth noting that to help commercial lunar landers be more successful, NASA is going to integrate their own experts into these companies to make missions more reliable. Of the 4 CLIPS missions so far, only Firefly's Blue Ghost Mission 1 was 100% successful. The first Intuitive Machines mission provided a large amount of data for NASA but toppled over, while the second mission was a complete failure. This is a more balanced approach from NASA, which previously had a hands-off approach to commercial landers. Due to the accelerated schedule, NASA needs more wins on the board, so to speak. In Phase 2, NASA plans 27 launches and 24 landings, and the deployment of 7 rovers. In total, 60 metric tons is planned to be landed on the lunar surface. Equipment landed will include moonfall drones, solar power stations, surface comms, and plenty of science. This phase should also include a nuclear power demo. This is not a reactor, but heating and power units that use radioisotopes. Phase 3. Permanently crewed moon base. From the mid-2030s, expect to see a near-continuous human presence on the moon. This phase will see heavier infrastructure, high-voltage DC microgrids, multiple connected habitation modules, and more. This phase will likely see the multi-purpose habitat from the Italian Space Agency deployed on the moon. This will be the first habitation module, signaling the start of the moon base. Canada will provide a lunar terrain vehicle in this phase, called the Lunar Utility Vehicle. This phase will see the transition from highly experienced and professional astronauts to potentially scientists and maybe even tourists. We've covered on this channel plans by GRU Space to build a lunar hotel. Expect to see commercial exploitation of lunar resources, mostly for lunar development and infrastructure. Companies like Interloon and Magna Petra have plans to collect helium-3 and return it to Earth for sale, a profitable business if they can master the technology to prospect and harvest this volatile element. In Phase 3, NASA mentions processing of lunar resources to produce water, propellants such as hydrogen and oxygen, and rare earth elements. Using lunar resources reduces the number of Earth supply missions, while enabling reuse of existing lunar landers. For instance, Blue Origin's Mark II lander is designed for reusability. Harvesting lunar soil and extracting hydrogen and oxygen would enable refilling of the lander's tanks, allowing for indefinite use. While SpaceX's Lunar Starship is unlikely to be refueled on the Moon due to methane not being abundant in lunar soil, oxygen can be generated and used to refill the tank. A single Starship can store 1,000 metric tons of liquid oxygen. In Phase 3, NASA plans 29 launches and 28 landings, 4 rovers, and the landing of 150 metric tons of payload to the lunar surface. The payloads consist of rovers, habitats, logistics, and at least one nuclear reactor, plus lots of scientific equipment and experiments. How space startups benefit from the phased approach. Jared Isaacman talked about 70% solutions at the NASA Ignite event. He was specifically referring to the SR-1 nuclear-powered spacecraft, but I think this approach is how the moon base will be built. With 30 landings over the next 3 years, space startups don't need a 100% solution to fly. In fact, Phase 1, the build, test, and learn phase, is basically the 70% solution phase. Try something and iterate on that solution, fixing what doesn't work and improving what does. No more gold-plated solutions, which was NASA's old approach to lunar operations. The later Phase 2 and especially Phase 3, with a permanent human presence, will also benefit lunar startups. For instance, equipment that topples over or becomes covered with dust can be fixed with an astronaut and a moon rover. This maintenance work from astronauts, if NASA permits it, will help accelerate lunar plans and operations for small startups, which can't afford to send their staff to the moon to fix problems. One issue I see when looking at the official renders is a lack of lunar infrastructure. For instance, I don't see any paved or sintered lunar roads or landing pads. This is surprising, as prepared ground, that is ground that's been leveled, compacted and treated, will eliminate lunar dust plumes caused by passing vehicles. Lunar landing pads prevent debris and ejecta being accelerated by landing engines that could pelt nearby lunar assets and kick up huge plumes of dust. It's also not clear to me how large space startups, such as SpaceX and Blue Origin, fit into this plan. Is Elon Musk's moon plans separate from NASA's? Will he be building his own moon base or contributing to NASA's? Final thoughts. With the Artemis 2 crew on their way to the moon and the Artemis 3 scheduled to fly in 2027, we are getting closer to humanity's return to the moon, this time to set up a permanent lunar presence. We now have a clearer, bolder vision for a moon base, using commercial companies to deliver services and operations needed by NASA to build and sustain a continuous human presence on the moon. What do you think of NASA's phased approach to building a moon base? Is this the plan we've been looking for? Do you think NASA will beat the Chinese back to the moon? Who are the winners and losers in this pivot? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Watch the weekly live stream to see the images, clips and slides from this week's videos. It's a live Q&A on this week's space topics where I read out some of the best comments. The more people join, the more fun the live stream is. Be sure to like and subscribe so you will see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.